Assalamu alaikum, hello and a good day. My name is Roydin Osman. Today I will be talking to you about the cloud data lifecycle and its control at different stages. As a case study, I have decided to select Amazon Web Services Cloud. This presentation summarizes the analyzing of security measures and access control across the AWS Cloud Data Lifecycle Security Architecture. As an introduction, in general standard, the cloud data lifecycle consists of 6 phases: create, store, use, share, archive, and destroy. These phases are referenced in both the National Institute of Standards and Technology (NIST) and the Cloud Security Alliance Models (CSA). Cloud security depends on securing all phases of the data lifecycle. So what does each phase do? Phase create ensures the right person or system is creating the data, which involves authentication. Phase store protect stored data from theft and leakage, which involves encryption at rest and access controls. Phase use allows only authorized users or apps to view or modify data. Phase share to control who gets access, how much, and for how long. Phase archive, keeping archive of all data safe, readable, and unchanged, which involves integrity and encryption. Lastly, phase destroy, to delete data in a way that it cannot be recovered. Ensure both main copies and backups are removed, and keep evidence of records of deletion for audit and compliance. A major learning point in this project is that each phase is connected. A weakness in one phase can cause a cascading failure across the entire lifecycle. I selected Amazon Web Services as the cloud service provider because AWS provides a comprehensive set of lifecycle aligned services such as IAM for identity control, KMS for encryption, CloudTrail for monitoring, and S3 for secure storage. AWS also has a well-documented real-world incident, such as the Capital One breach in 2019, which allows strong practical grounding for this analysis. For this AWS cloud diagram, it provides a full view of AWS security controls aligned to each data lifecycle phase. In create, users or apps submit data via web forms, APIs, uploads, sensors, or logs. Data moves from endpoint to cloud entry point. Data is ingested through secure endpoints such as AWS API Gateway and immediately protected with transport layer security, IAM roles, and CloudTrail logging. In the store phase, data is saved in storage such as object, block, database, backups, logs. Long-term durability and integrity becomes the focus. AWS encryption at rest, S3 block public access versioning, and object lock provided strong data durability and immutability. The use phase, AWS Cloud computes VM, virtual machines, containers, functions, and database query. It reads and processes data. This is often the most active and attacked phase. AWS introduces runtime controls including EC2, IAM roles, Nitro enclaves, AWS Guard Duty, Inspector, and network segmentation. In the share phase, data is exposed to other users, apps, partners, or the public. Data can be direct downloads, APIs, or via services such as CDNs and reports. AWS uses IAM boundaries, pre-signed URLs, CloudFront signed URLs, and a AWS private link to minimize exposure. Finally, archive and destroy phases. Old but still needed data is moved to cheaper and cold storage, often driven by compliance or business retention requirements. Next, the data is intentionally removed when no longer needed. The goal is to make recovery practically impossible. These two final phases rely on AWS Glacier, lifecycle rules, worm retention, and KMS key deletion for irreversible data removal. This diagram highlights that cloud security is not siloed. AWS services such as Identity and Access Management (IAM), Key Management Services (KMS), CloudTrail logs, and VPC-based network control spans every phase of the lifecycle. For example, a single IAM misconfiguration can compromise, create, use, store, and share phases all at once. Similarly, encryption implemented in store phase is meaningless if IAM permissions allow decrypt anywhere usage in use or share phases. This demonstrates that cloud security must be implemented as an integrated architecture. Moving on to the Capital One Bank case study. The Capital One cloud data breach is a perfect example of lifecycle misalignment. The attack began with a server-side request forgery that allowed the attacker to query the EC2 instance metadata service. From there, the attacker stole temporary IAM credentials, which should have been tightly scooped. Because the IAM role was overprivileged, the attacker legitimately accessed AWS S3 bucket, including data containing credit applications. Even though encryption and other control existed, IAM permissions allowed the attacker to perform AWS S3 list, get, and even decrypt operations via AWS KMS. This case demonstrates three lessons. 1. Identity is the parameter in cloud environments. 2. IAM misuse can span multiple life cycle phases. 3. Logging without alerting is not security. AWS CloudTrail captured the attack, but no alerts were triggered. In conclusion, this assignment has helped me to understand that cloud security requires consistent protection across all 6 lifecycle phases. IAM, encryption, monitoring, and network controls must reinforce one another. The Capital One case demonstrates that one misaligned control, especially in identity, can override even strong encryption and network boundaries. Cloud data lifecycle security architecture. Base security is not optional. It is essential for modern cloud environments. I hope this knowledge finding and exchange will give you a bit of insights and purpose which involves the cloud data lifecycle security measures. Thank you for your time.